Hello guys, so we are back again, and in this session we are going to do uh, some more questions on Euler's theorem. And there are total 4 theorems, but we have the rest 2 are just the modifications, the other form of the 2 theorems. But we have done 2 questions in the last lectures on the basis of the 2 theorems. The theorems were as follow: x dou u by dou x plus y dou u by dou y equals to n into u. The second theorem was x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou square u by dou y square equals to n into n minus 1 into u. Right? So now let's take some more questions. But before beginning with the lecture, I want to suggest you guys to please subscribe the channel so that we can bring more engineering content for you guys. Now let's begin with the question. The first question which we are going to take is as follow: if z equals to log x square plus y square plus x square plus y square by x plus y minus 2 log x plus y, find the value of x dou z by dou x plus y dou z by dou y. Now first what you should do, you should write z, which is x square plus y square plus x square plus y square by x plus y minus 2 log x plus y. Now see whether there can be any modification in z or not. Yes, here there can be modification. I can write it x square plus y square. I can move this 2 power here and then apply log a minus b equals to log a by b formula, which will be x square plus y the whole square, and here x square plus y square the x plus y. Now here you will say that we are having 2 different functions, and as per what you have thought, the Euler function was applicable for only one function. Yeah, it was applicable for one function, but you can apply it for 2 by considering them different function and verifying each of them separately whether they are homogeneous function or not. Now what we will do, let v equals to log x square plus y square by x plus y the whole square, and u equals to, sorry, u no, not u, we will take w equals to x square plus y square by x plus y. Right? What we are going to do, we are going to prove first that v is homogeneous or not. So put x is equals to lambda x and y equals to lambda y in v. What we are going to get, v is lambda x comma lambda y. I will write it in this format to let the teacher know the standard format when a function is homogeneous, how we represent it. Log, here it will be lambda square outside, lambda x square plus y square. Some steps I skip because they are just redundant steps, they don't make any much sense. You will understand, but you should do in as many steps as you can. And here what we are going to get, lambda square again x plus y the whole square. So you can clearly see our lambda square will cancel out. We are finally left with lambda power 0 log x square plus y square the whole by x plus y the whole square. Right? We are left with this thing only. Now what we are going to do, you can clearly see that the power here is 0. So we will say what? And we have verified that is a homogeneous function by writing this step v of x comma y. Now we will say here v is a homogeneous function of degree n equals to 0. N equals to 0. You have to mention the degree also. N equals to 0 in variable x comma y. Right? Now what we are going to do, since it is a homogeneous function, I can apply the Euler's theorem. Since the required proof is this, so I am about to use the Euler first theorem, which says x dou v by dou x plus y dou b by dou y is equals to what? N times v. As per this, v is the function, but n is 0, as you can see, so it will be equal to 0. I will write it 1. Similarly, put x is equals to lambda x and y equals to lambda y in w. What are you going to get? W lambda x, lambda y equals to what we have? We have it as x square plus y square by x plus y, which will become lambda square x square plus y square the whole by lambda x plus y. Okay, so you can see one lambda we cancel out and we are finally left with lambda power 1 x square plus y square the whole power x plus y. Now which you can say as lambda w x comma y. So here it has been proven that it is a homogeneous function, but you have to write that line here. W is a homogeneous, means HF, okay, homogeneous function of degree. Degree is very important, you need to mention it. Degree n equals to 1 in variables x comma y. Okay, you have to mention the variables also in variables x comma y. So we are done with the variables thing. Now we can say by Euler's theorem, what we can say, x dou w by dou x, y dou w by dou y is equals to, here we have n times w, which n is 1, so I will write it w. Now what we wanted to prove, what we wanted to get the value, we wanted the value of x dou z by dou x plus y dou z by dou y, right? But z is what? If this is z, I have considered this v and this as w, so my z is nothing but v plus w. So I can replace z by v plus w in each of them. So dou by dou x into v plus w plus y into dou by dou y v plus w, which will further be simplified x into dou v by dou x. What we are getting? X into dou v dou w by dou x plus y into dou v by dou y, y into dou w by dou y. Now I have these two values and I have these two values, so I will collect them and I can put this value, the v value is 0 from 1 and this value is w from 2. So here you have to mention from 1 and 2. After doing this, you know the w value is what? W value is x square plus y square by x by 2, so it is x square plus y square by x plus y. Okay, so we are done with this thing. Now let's move to the next question. Hope you have understand each and every step. I tried my best. Now let's move on to the next question. The next question which we are going to take is as follow. If z equals to x power n f of y by x plus y power minus n g of x by y, prove that x squared dou square z by dou x square plus 2xy dou square z by dou x dou y plus y square dou square z by dou y square plus x dou z by dou x plus y dou z by dou y equals to n square z. Okay, now we have to do what? We have to write the z first. That is the first step. F of y by x, y power minus n g of x by y. We have to mention here since there are two different functions, we will consider each of them. Here v equals to x power n f of y by x and w equals to what? Y power minus n g of x by y. Okay, now we have to prove whether they are homogeneous function or not. But since I have already told you that this is the general format of representation of homogeneous function if they are homogeneous. Okay, remember. But since the examiner wants the proof, okay, we have to prove it. So first we are going to put x is equals to lambda x in v, x equals to lambda and y equals to lambda y in v. What we are going to get? V equals to lambda power n x power n, f of this 2 lambda will cancel out and we are going to means left with same equation. So lambda power n into v of x comma y. So finally here it will be lambda x comma lambda y v of lambda x. So here we will write this line here. V is a homogeneous function of degree. What is the degree? Degree n equals to n. In variables, what are the variables? In variables x comma y. Okay, in variables x comma y. After doing this, okay, by Euler's theorem,
here you can directly make out that I require both theorem 1 and theorem 2 both the needs, because here x square dou square z by dou x square is present, 2xy dou square z by dou x dou y is present. Here also singular terms are also present, x dou z by dou x plus y dou z by dou y. So I am going to derive both the things. What? X dou v by dou x, y dou v by dou y is equals to n times v. This is the one equation. The other equation will be what? The other equation will be x square dou square v by dou x square 2xy dou v by dou x dou y plus y square dou square v by dou y square is equals to, what is the value? What value we are going to put here? N into n minus 1 into v. This is my second equation. Similarly, put x is equals to lambda x and y equals to lambda y in w. We are going to get w lambda x comma lambda y equals to, what we are going to get? Lambda power minus n x power minus n g of x by y. Okay, which you can understand directly because terms are cancelling out. So I'm not going to write that. Lambda power minus n g, this is w x comma y. So we have proved. Okay, we have proved here. So here I will write here w is a HF, homogeneous function of degree. What is the degree? Degree is nothing but n equals to minus n. In variables, in what variables? In variables x comma y. Okay, in variables x comma y. So we are done with this part. Now we are going to use by Euler's theorem. By Euler's theorem, what we can say? X dou w by dou x, y dou w by dou y equals to n times w. N is nothing but minus n times w. So we are left with this thing third. And similarly, x square dou square w by dou x square plus y square dou square w by dou y square plus 2xy dou square w by dou x dou y is equals to, n is what? N into n minus 1 into w. But my n is what? Minus n. So minus n into minus n minus 1 into w. If I take minus outside, this will become plus. So n plus 1 into w. Finally, I will call it as fourth equation. Now what we are going to do? We are going to see the required thing which we wanted to prove it. So the required thing which we wanted to prove, LHS, is nothing but x square dou square z by dou x square plus 2xy dou square z by dou x dou y, y square dou square z by dou y square, x dou z by dou x, y dou z by dou y is the thing which we require. We are going to replace, put xz equals to v plus w. The moment I put, I will get x square dou square v by dou x square. You can do that step. Y square dou square v by dou y square, y square dou square v. So we are done with this one. Now with this one we are going to left with 2xy dou square v by dou x dou y plus 2xy dou square w by dou x dou y plus, here we are going to left with y square, it will be x square dou v by dou x square, and here y square dou v by dou y square w by dou y square, and last thing x dou v by dou x dou w by dou x, y dou v by dou y dou w by dou y equals to what? So here you can make out this dou v, this one, here it is w. Okay, this all three combined value is nothing but n into, not this one, we have its value here, n into n minus 1 v. So I can put here n into n minus 1 into v. Similarly, this thing, its value I have as n into v plus n into v. Similarly, this its value I already have as n into n plus 1, n into n plus 1 into w, and finally this thing and this thing, its value I have as minus nw. If we simplify, what I'm going to left with, n square v minus nv, and here n square w, nw minus nw. These are cancelling out, this cancelling out. If I take n square common, v plus w is left. I am getting answer n square z, which is the thing which we wanted to prove if you see clearly. So hence proved. Now let's move on to the next question. So the next question which we are going to take is, if u equals to x cube sine inverse y by x plus x power 4 tan inverse y by x, find the value of x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou square u by dou y square plus 2 plus x dou u by dou x plus y dou u by dou y at x equals to 1 and y equals to 1. Okay, now we have to write here this equation first. Here you can see the similar pattern will be observed and same thing will be done like we did in the just the previous question. What we have to do, we have to assume them. Let x cube sine inverse y by x equals to v, and x power 4 tan inverse y by x equals to w. So what we are going to get? We are going to get u as v plus w. This thing keep it as 1. Now what we are going to do, put x equals to lambda x and y equals to lambda y in v. What we are going to get, v lambda x comma lambda y is nothing but lambda cube x cube sine inverse y by x. So we are getting nothing but lambda cube v of x comma y. So we are going to write the statement. So v is a HF homogeneous function of degree n equals to 3 in variable x comma y. We got this thing in variable x comma y. After writing this thing, what we can do in variable x comma y, we can use by Euler's theorem. By Euler's theorem, we can write this following statement: x dou v by dou x, y dou v by dou y is nothing but 3 into v. Okay, we are getting 3 into v. So in the next statement, x square dou square v by dou x square, y square dou square v by dou y square, and 2xy dou square v by dou x dou y is nothing but n into n minus 1. So 3 into 3 minus 1 into v, which is nothing but 6v. So we are getting these two things. I will call it as 2, I will call it as 3. Now similarly put x is equals to lambda x and y equals to lambda y in w. So w lambda x comma lambda y equals to lambda x comma lambda y. What we are getting? We are getting lambda power 4 x power 4 tan inverse. This both will cancel out and will remain as it is. So lambda power 4 w x comma y. So we are going to write that w is a homogeneous function of degree. What is the degree? N equals to 4. In variables x comma y. After writing this, we will write by Euler's theorem. What do you will write by Euler's theorem? X dou w by dou x, y dou w by dou y is nothing but n into w. N is what? 4. So 4 into w. I will call it as, this was second, third, and this is fourth. Similarly, x square dou square w by dou x square plus y square dou square w by dou y square plus 2xy dou square w by dou x dou y is nothing but n into n minus 1, so 4 into 4 minus 1 into w, which is nothing but 4 into 3 into w, which is 12w. So we are going to write it as 5. Now if you observe the proof, so from this, if you add, or you can do just write this statement, x square dou square plus dou x square plus 2xy dou squared u by dou x dou y plus y square dou square u by dou y square plus x dou u by dou y dou x plus y dou u by dou y equals to what? Okay, so what we are going to do, we are going to put u equals to v plus w from 1. The moment you put x square dou square v plus w by dou x square plus 2xy dou square v plus w dou x dou y square dou square v plus w, here dou y square, and x dou by dou v dou x v plus w plus y dou y v plus w, right? If I open this, x square dou square v by dou x square, 2xy dou square v by dou x dou y square dou square v by dou y square, dou square x square dou square w by dou x square, y square dou square w by dou y square, and we are getting 2xy dou square w by dou x dou y, then x dou v by dou x, x dou w by dou x, y dou v by dou y, and y dou w by dou y. This is what we are doing. But from what we can say, from 3, 4 and 5. Okay, you know we have all of these values. So what we are going to mention from 3, 4 and 5, right? From 3. So what we are going to mention from 3, 4 and 5. Let's substitute all the values. What we are having is from 3, 4 and 5. What values we are having is 3v plus 6v, 3v plus 6v plus 4w plus 12w. Now we know what is v. V is nothing but x cube, so 3 into x cube sine inverse, let's write it 9 into v plus 16 into w. So what we are getting finally is, everything is proper, right? 2, 3, 6. Here it is n into n minus 1, n equals to 3 was there, it is 3, 4, 3, okay, 12, and this is n, which is 4. Okay, so we are having here 16. So I am going to substitute the v, which is x cube sine inverse y by x, and this is what, 16 x raised to 4 tan inverse y by x. If I substitute, put x equals to 1, because I want at x is equals to 1 and and y is equals to 1. At x is equals to 1 and y equals to 1, this will be 9. Sine inverse 1 will be at what? And 16. This will become 1 power 4, and this will become tan inverse 1. 9. This will become pi by 2. This will become 16 pi by 4. Tan inverse 1 is at pi by 4. So here this will become 9 pi by 2, and this will become pi by 4 pi. So if you, this will become 9 pi plus 8 pi by 2, which will be nothing but 17 pi by 2. So this is our answer. Hope you have understand each and every step. We have completed all the steps of this question. Okay, now let's move on to the next question. Okay, now we are going to take the next question in the next lecture. So we are done with this session. In the next session we are going to take some more questions. Till then, revise these questions Okay, and see you in the next video. Hope you have enjoyed the lecture. Thank you.